Hey everybody. Today what you're going to see is a clip from a bigger video on sketching exponential functions. What we're going to do is we're going to take an exponential function and we're going to examine it through transformations and sketch it using a horizontal asymptote, a y-intercept, and something that I call a transformed intercept, where we take the base function's y-intercept, that is the point at 0, 1, and where it gets transformed to. So I hope that this example helps you out, and if you need any further examples, hop on to the video that it came from. Okay, best of luck, everybody. Okay, what I would like you to do is to go start to finish on C. So let's find all three of our properties first. If you're feeling super confident, then work your way through and start to build your sketch. You know you have a means to check. If you're not so confident, then maybe let's come back after we've found our three properties and we should be good. Okay, so I want you to pause it now. Okay, so we're back. So I'm just going to try to keep like the same kind of color coding system. So first thing I'm going to do is find my horizontal asymptote, and I should be good that that has to exist at 4. Y equals 4. Now I'm going to go through and I'm going to find my transformed intercept. That means I need to be able to interpret everything in that equation as transformations. So the first thing I notice is that I'm going to end up dealing with a vertical stretch. So I'm going to take my old intercept that I know always existed at 1 and now deal with a vertical stretch by a factor of 3. That gets me up to 0, 3. Now I can go through and I can move up into the exponent, but I notice that I need to factor out that negative from in front of my x so that that is multiplied by everything on the inside. I'm going to bet and say if you made a mistake on this one, that was probably it. I just want you to note that if you viewed that as being a reflection in the y-axis and then a shift left 1, you will have found your mistake if you use the direction of the curve as a check. Okay, I'm not going to make that mistake, and I'm able to go through. For anyone who did make that mistake, I would suggest pausing it again and trying to finish off the problem again and seeing if we match up in the end. Okay, that reflection is going to have no impact on that intercept. I'm on the y-axis, so to reflect my curve across the y-axis means it did not change. I now shift it to the right 1, and now I finish that off by shifting it up 4. My transformed intercept should be at a finishing position of 1, 7. So I'm just going to get rid of all that stuff. I'm maybe going to keep that factoring in, but I'm going to change the color of my transformed intercept because I can now see it just all in blue. Shift it to the right 1, up 4. Okay, now I need to find my new intercept. So to find my y-intercept, that means my x value has to equal 0. And so when I make that substitution, I'm going to sub it back into the original, not my factored form, because that's going to give me this to calculate. So I can calculate my 3 times 2, there's a 6, add on my 4, there's my 10. Okay, I'm going to plot all my information. On my y-axis, I have to get to a 4, to a 7, to a 10. What that might mean then is when I put on my horizontal asymptote, I'm not going to move that far off the axis. If, let's say, I make that be about 4 units, then I can plot the point at 1, 7 pretty well, and I can put my point at 10. And all that stuff is relatively proportional. Okay, the only way that I can connect all of that stuff is to have a decreasing curve. So I'm going to do my check. Okay, my base of my function is a 2, so I know I'm starting with a rising curve. If I vertically stretch that, that has no change, so I'm still increasing. But as soon as I reflect that in the y-axis, that means I have a falling curve. I'm now decreasing. The rest of my transformations are shifts. Shifts do not change the shape of my curve. I know that I should have a decreasing curve, and that matches with what I have. So the only thing left to do, let's go ahead. My transformed intercept should be a relatively hard turn. And so now I go really flat as I approach that asymptote. Arrows on the end, and we should be good. Okay, hopefully we matched up, and we were pretty solid doing so. My suggestion to you is get used to that algorithm, that process. Find your properties first. Go ahead, put them on your graph. Use the direction of your curve as a check. And just remember that if your transformed intercept and your new intercept happen to be the same thing, then we need to go and find a smart point and just try to be as smart as you can in your selection. Okay, hopefully we're good for today. Job now, jump in and get some practice. Okay, best of luck.